is a video for AQA Discrete Mathematics. This is linear programming section 1.3, where we're looking at the objective line method for solving linear programs. Well, we've seen already that if we plot the constraints onto a graph, then we can solve for a solution by looking at all of the vertices and seeing which of those gives us either the maximum or the minimum for the objective function. Now, you may need to check several vertices to make sure you've found the optimum one. So this can actually be quite time consuming, particularly if we've got tricky simultaneous equations to solve. Even if you're using a calculator to solve your simultaneous equations, it can still be quite time consuming. Remember, if you do use a calculator, that you must show the equations that you are solving in your solution to gain credit for the solution. So what we really like to do now is to decide, well, instead of checking several vertices by doing this sort of method, can we decide which of the vertices is the optimum one before we do the simultaneous equation work? And this is what we call the objective line method. Now here's the constraints that we had in the last video, and remember that we're trying to maximize our function. So what we need to do is to say, well, let's look at one particular value of the profit. So for example, we could look at the profit P being equal to 12. So if that was the case, I choose 12 because 3 times 4 is 12. So if I had profit equal to 12, then that would give me 3x plus 4y equals 12, and remember that that line is going to cross the x-axis at 4 and the y-axis at 3. So there it is, there's the line. Now that's one profit line. If we wanted to maximize our profit, then we simply need to take that line and move it further and further away from the origin, so in this direction. And one way of doing that is to place a ruler on the line and then literally move the ruler parallel to that. There it goes, and you can see that the last vertex that it is going to leave the feasible region at is the one I've just indicated there. So we know which of the vertices is going to give us our maximum. Let me just put that ruler back there. We've drawn our line, and now we're going to move it until it leaves the feasible region, or we find the last vertex. And that's at the intersection of the lines y is equal to 3 and the other line is the line x plus y is equal to 5. So we do that solving and we see that that gives us the point x is equal to 2 and y is equal to 3. So this is the point x is equal to 2, y is equal to 3, and therefore our maximum profit P must be given by 3 multiplied by 2 plus 4 multiplied by 3, which is what we had before by checking the vertices. Of course, that gives us the value 18. Now, if we want to minimize, it's the same equation. So there's our first line. This time we simply need to move it towards the origin and look at the last point. And we can see that the last point that we leave is this one here. And that's where we have the two equations. The first one is this line here, which is the line which is 2x plus 5y is equal to 10. And the other line is this line here, which is the line where we have 5x plus y is equal to 5. So we could solve simultaneously the two equations, 2x plus 5y equals 10 and 5x plus y equals 5. So the advantage here is that rather than checking lots and lots of different vertices to see what the profit is. We know which vertex. We still need to solve the simultaneous equation to work out the values of x and y, and then to work out the value of p. That's the end of that method, looking at the objective line method. In the next one we'll consider what happens when we need to find integer values. You'll notice in particular the second example there that we looked at the solution in the previous video gave us numbers which were certainly not integers as being our solution.